4.8, number 5, Tony and Dermot often run quarter-mile races. A quarter mile is about 440 yards. Dermot's best time in the race is 1 and 3 over 8 minutes. Tony's best time is 1.5 minutes. Who has the best time? Okay, so we are basically comparing 1 and 3 over 8 and 1 and 1.5. 1.5. So let's change it to the improper fraction. Change it to the improper fraction. So we'll have 8 times 1 plus, so it's 11 over 8. And this will be 3 over 2. Now we cannot compare these two yet, so we have to find out the great denominator, least common multiple of these, and then convert this to the equivalent fraction. So 3 over 2 will be some number over 8. Then compare those two, and obviously the more you have, the slower you are, right? In the race. So that's that. Exercise 6 to 8 are about a quarter-mile race that Dermot and Tony run. In this race, Tony had a 20-yard head start. Assume that both matched the speed of their best time given in exercise 5. Sketch the distance time graph that shows. Okay, so distance time graph will be, oops, so distance time graph will be, again, time is always on the horizontal axis, and the distance is on the vertical axis. And we have 0 here. So the time will be probably, 15 seconds, 30 seconds, 45, 1 minute, 60 minutes, and so on and so forth. And then I would have the interval of 10 yards, so I would put 10 yards, 20, 30, and then make a graph. So the important point here is 20 had a head start. That means at 0 second, he is at 20 seconds ahead of the start line. So the 20's first starting point should be right here. Okay, so keep that in your mind and complete the graph. And then after you draw a graph, you should be able to answer problem number 7. Right about. As you walk down the sidewalk, you see someone walking ahead of you. Although you do not know how fast either of you is walking, you realize that you're walking faster than the other person. If you both keep walking at the same speed, will you eventually catch up? Common sense. I don't think I need to. So just write it down and make sure to explain very detail of your reasoning. Not just a conclusion, but I'm more interested in your reasoning. The next one, you see someone walking ahead of you again, the same deal. Oh, wait a minute. This is the one that we just did. Wait a minute. Is that the same problem? No, it's not the same problem. Okay. So the same situation. You're walking at exactly the same speed as the other person. If you both keep walking at the same speed, that means, so if you're walking at exactly the same speed, so would you catch up? Would you be able to catch up if you walking at the same speed as the other person? Common sense. And explain why. Problem number 11, standardized test prep. Mrs. Merrill drives from Dallas to St. Louis. The length of the trip is 650 miles. She travels 50 miles per hour. That means in 2 hours she would be at 100 miles away from her starting point. And her husband leaves 2 hours later and travels 62.5 miles per hour. So her husband is faster to catch her up. And so at what distance from Dallas will Mr. Merrill catch up with his wife? So at what point? Okay, so obviously Mr. Merrill will catch her up at some point, but the question is, can she catch up? Can he catch up before his wife reaches at St. Louis? So one of the good strategy is to probably, you can guess 500 miles. What would happen? What would be, where would, how long would it take Mrs. Merrill to get to 500 miles? Or how long does it take for Mr. Merrill to get to the 500 miles? If those numbers are the same, or you know, you can see the patterns right here, and make sure you think about the reasoning as well.